graph the plane curve defined by the parametric equation. X is equal to t squared plus 1, y is equal to 3t, and is in the interval, in the closed interval from minus 2 to 2. So t is between minus 2 and 2. So first of all, let me make a table to find out the values of x with respect to t. So let me take a pen here and let me graph it. Let me graph the table. So this is the table. So let's say here is t, here is a x. And I'm taking some value of the t. Let's say is from minus 2, minus 1, 0, 1, and 2. If I'm plugging minus 2 here in this equation, it is going to be 4. Plus 1 is a 5. So I'm evaluating the values of x with respect to t. If a t now is a minus 1 square is 1, plus 1 is 2. And now if t is a 0, so for this value, if t is a 0, 0 plus 1 is 1. And now if t is 1, 1 square is 1 plus 1 is 2. So that's what we have here. And if t is a 2, 2 square is a 4 plus 1 is a 5. Okay, so these values. And now, so let me take another table that we find the values of y. Let's say here is a t and on the other side y. And let me take the same value because the t is in this closed interval from minus 2 to 2. So let me take minus 2, minus 1, 0, 1, and 2. And now I'm going to evaluate the y with respect to t. So if t is a minus 2 times 3 is minus 6. So this is minus 6. If t is minus 1, 3 times minus 1 is minus 3. And now, if t is a 0, 3 times 0 is 0. So y is 0. If t is 1, 3 times 1 is 3. Okay, and if t is 2, 3 times 2 instead of the t is 3 times 2 is 6. So y is the 6. So now we have those values. And let's plug this value in. But let me take this value here for the x axis. And now in x-axis I have in from 1 to 5. Okay, so let me say here is 1, 2, 3, 4, 5. 2, 3, 4, 5. Those value I need. But for the x, I need from minus 6 to 6. Let's say minus 6 is here somewhere. Okay, minus 6 in the half is a minus 3. And let's say here is a minus 1. And here I have 1 because I'm going up to 6. 0 is here. Okay, so I have a minus 3. Let's say 6 is here somewhere. And half of it is a 3. So this is a 3. So those value what I have. And this is a 0, of course. This point here, the origin. And now if x is a 5, y is minus 6. So x is a 5 and y minus 6 is this point. So I'm trying to grab those points now. And now if x again is a 5, you see the y is a 6. So it's going to be this value. x5 and y6. So let me write this is y and this is x. And now if x is 2, y is a minus 3. Okay, x is 2 and y is minus 3 is at this point. But this point here, let me write here this one. So this is a t was 5. Okay, so t was 5. So let me erase this one. So let's say, okay, so t was a minus 2, okay? So minus 2, and x was a 5, and the y was minus 6. So this point here. If t here was 2, what happened with the y? X was a, and here, yes, is a 5, and y is a 6. And now I'm going to this point here. When t, for example, is a minus 1, okay? So x is a 2, and y is minus 3. So this point here. But in this point, I can write. So t is a minus 1, and x is a 2, and y is minus 3. This point. And in this point here, 3, again, t is minus 1, x is a 2, so let me take this parenthesis, and y is 3, positive 3 in this point here. But now in 0, t in 0, x is 1 and y is 0. So it's this point here. So in this point here, so let me write here. So t is a 0 and x is 1, y is 0 at this point. And now I'm just connecting all these points together, and we can graph the curve. And curve going up to here, to this point. And now I'm connecting those points here, and the curve is up to here. So this is the curve of the plane curve defined by the parametric equation x is equal to t squared plus 1, y is 3t in this interval here.